So we are continuing the lab that is exploring how unbalanced forces affect acceleration. And now we're going to begin experiment 2, which looks at acceleration versus mass. So in this experiment, the independent variable is going to be the mass measured in kilograms, and the dependent variable will be acceleration, which is measured in meters per second squared. The constant in this experiment will be the net force. Okay, so we are going to go and set up the FET in exactly the same as we did for the experiment 1. So I'm going to put checks in every box except for speed. I'm going to move the friction to none, and I want to change this button so that it will not play until I tell it to play. Okay, so I've clicked this button to make it the arrow. Okay, we want to choose a value of applied force that's equal to 400 newtons. And so I'm going to go back to our simulation and choose 400 newtons as the value of applied force. Because there's no friction, that applied force is also the net force, the sum of the forces. Okay? And the thing that will change in this experiment is the mass. Okay, so I'm going to begin creating this table here at step 21, and I see that the first mass is 50 kilograms, so I'll just go ahead and fill that in, and I'm going to now run the simulation for a second so that I can see what the acceleration is when there's 400 newtons of net force on a 50 kilogram mass. Okay, and I see a value of 8 meters per second squared. So I fill that in my table. Now I'm going to go change the mass. So this simulation tool will allow you to stack up to 3 types of mass, and you have things that you can bring in from the left and also from the right. So I'm going to start, I don't know, you can choose your own combinations, but I'm going to put this man and see he's going to sit on top of the crate. So now my combined mass is 80 plus 50, which is 130 kilograms. So I fill that in the table. I am not going to change the applied force because that should stay constant, but I'm going to run the simulation for a second to see how the acceleration has changed. Okay, and I see now the acceleration with this additional mass is 3.08 meters per second squared. Okay, and then I'm going to change the mass again. Maybe I'll let this gentleman hold this bucket that has 100 kilograms of, actually maybe I don't want to do that. Maybe I'm going to put the girl up here first. So he's going to hold the girl. So now my combined mass is 40 plus 80 is 120 plus 50 is 170 kilograms. Okay, so 170 kilograms. And I'm not changing the applied force. I'll leave that the same. But I'm going to run the simulation, and I see that now the acceleration is 2.35. And so I'll continue doing this type of thing until I have this table filled in with 6 different amounts of mass. So you need to have at least 6 rows filled in this table.